Hello, I'm Mehmet Uygur,
Hello, I'm Ahmet Şen.
and we are the Friday afternoon laboratory session and
Ninth
our
group.
ninth group, and our assistant is
Ayşe Deniz Duyul.
yes. And in our project, we try to make a solar tracking system, and in order to do the system, we had 4 units. The first unit was the lightning sensing unit. Second was comparator unit. Third one was
PVM unit.
PVM unit, and fourth one was the RGB unit. Let's talk about the structure of the LDRs and sensing unit. When the light goes on the LDRs, LDR resistance and goes down, and voltage across the LDRs is going up. And for example, let's say light intensity of the A is highest, second and third, and then our voltage we get, VA is bigger than VB, and VB is bigger than VC. And for example, highest intensity goes the LDR2, and second is LDR1, VA, and the third one is LDR2, and then VB becomes the bigger than VA, and VA is bigger than VC. Let's say LDR3 has the highest intensity of light, LDR2 is second one, LDR1 is the third one. Then it means that voltage across this side, VC is bigger than VB and is bigger than VA. And in order to get the voltage, we use voltage division in 3 LDRs, and this voltage goes to op-amps, and Ahmet will talk about the comparing system.
In comparison unit, we use op-amps. Let's say VA has the highest intensity, and in this op-amp it compares VA and VC. Let's say we say that VA is the highest, so VA is greater than VC, so it's in plus sat region, so VA continues here. And this op-amp compares VA and VB, so we said that VA is greater than VB, so plus 12 voltage continues, and we take the output as plus 12. So this op-amp compares VA and VB. We already said that VA is greater than VB, so ground, we have ground in minus sat region, so ground continues, and we compare the 0 and the VC, so VC is greater than 0, so 0 continues again, so we get none output here. And we compare VB and VC, so let's say VC is greater than VB, so VC continues, and compare VC and VA. VA is greater than VC, we already said that, so ground continues, and we take 0 output. So if VA is greatest one, so we take plus 12 output here and 0 outputs here.
According to specification about this project, when we try to get the 90 degrees of servomotor motion, we also need to get purple color in RGBs. And in order to get the 30 degrees of the servomotor motion, we also need that yellow color of the RGB. In order to get 150 degrees of the servomotor motion, we also need that orange color from the RGB. And let's talk about how we use RGB to get these colors. For example, let's say we need to get 90 degrees of motion, and
so we need purple.
We need purple, and in order to get the voltage here, VB must be highest, and it means that highest intensity voltage across the LDR2. And when highest intensity of the light is VB, we have only here 12 plus voltage, and this voltage, as we can see from our RGB system, one current goes the red side of the RGB, one current goes the blue side of the RGB, and we connect the grounds, circuits grounds and the RGB ground, and RGB give us the purple color. And in order to get the 30 degrees of the servomotor motion, we need to get highest intensity of the LDR1, and we only get here plus 12 voltage. And in order to get the color of the yellow, we set the voltage and current one side of the red and one side of the yellow side of the RGBs, and we get the yellow color. Moreover, in order to get 150 degrees of the motion of servo, we need to get LDR2 had to has highest intensity of the light, and then we had only here plus 12 voltage, and this voltage again goes to red side and green side of the RGBs, and the difference is between this. To become to orange, we need like 3 times bigger red voltage than green side of the RGB, and we get the orange color.
In PWM unit, we have 3 different PWM generators for each angle, 30, 90 and 150. In 30 degree PWM unit, we take the output taken by this comparator to this op-amp's plus sat, and in 90 degree PWM unit, we take the output taken by this op-amp to this op-amp's plus sat, and for 450 degree PWM unit, we take the output taken by this op-amp to this op-amp's plus sat region. So if let's say VA has the highest intensity, so this output is plus 12 and the other outputs are 0. So all this plus sat is plus 12 and the others are 0. So only this 30 degree PWM unit works and others does not. So this PWM unit works. This PWM unit generates 30 degree PWM. So our PWM unit is a square wave generator, and our design we have diodes and voltage division. So we change our square wave into a pulse width modulation, and this resistance are controlling the period and the cycle.
And when we generate this square wave, this diode helps the make zero of the negative side of the square wave, and we easily get the pulse. And as you can see, we use voltage division here to use the voltage to go to the motor, and servo motor works when the VA is the highest.